one. Howdy, everyone. Young and old joining the Flow Developer Hours number 6. Really happy to have all of you, but especially the awesome Jacob. Say hi, Jacob.
You know it. Hey everybody, how's it going? Good to be back.
Jacob's been
Woohoo!
gone, absent when we've missed him, and it's really great to have him back. Um, so, with that out of the way, we should review a little bit last week, and starting with the hackathon. We're just gonna say hi to everyone. Justin's in the chat. My man, always there, supporting. Thank you a lot.
Hey Justin.
Sedix, Ben, who else we got in the chat? It says we have 5 concurrents. We appreciate each and every one of you. So yeah, last week we got to explore a little bit how to set up an app that can communicate with the Flow testnet. It's a solution that's you could say quick and dirty, but it gets the job done in terms of learning about Flow. Wouldn't you say, Jacob?
Yeah, it's pretty
And
good.
we created a repository with a very appropriate name when you're working on something blockchain related or any kind of software. I mean, let's be real, software is difficult. The repository is called Mercury Hopium. I'm going to share the link in the chat on YouTube. And enter. When I click enter, I hope to see. Okay, the message is out. I'm going to share the link on Slack as well. So this is the repository that we're going to explore again today. But this is the place where we get started with testnet. Hey, Amal. Always nice to have you.
Hey Mal.
And you know, the best way to start building something is to try and replicate what others have built and see if you can iterate on what they have. And I mean, God knows when we build stuff, even after months and months of experience with Flow, we still look at the existing material, right, Jacob? Like, what's your daily sort of cadence workflow? All original?
Yeah, I would say a lot of copy pasta going on. Viewing the docs and going over NFT marketplaces 15 times a day.
Right. It's part of the the developer ethos. You try and look at what others have done, what works, and try and replicate that. So what we're gonna do is we're gonna switch gears and go into screencast, and over there, hopefully y'all can see. I'll bump up the font a little more, and over there we're just going to add some more features and see how we can improve this contract. Maybe add some fungible tokens, maybe some non-fungible tokens. What do you think, Jacob? What would be a good addition?
Yeah, let's do some NFTs because I think that's pretty popular right now, and it might be fun to get people looking at how NFTs are actually represented at the smart contract level. Because at least for me, I didn't really understand why NFTs were so special until I started to learn how they're actually implemented in smart contracts and why that security and uniqueness actually came into
Fair
play.
point. So let's hit the road with cloning the repository and with exploring these NFTs. And if y'all don't mind, we're gonna fire up VS Code here, and I'm looking for some confirmation as to. Oh, let's go deeper. Looking for some confirmation as to the font sizes, if it's all legible, if you guys can read it. That's what we need. Okay, laying it out there. Bump it up. I think that should be good. Okay, and this is a create React app, so we can just npm a run start to get it going. Oh, yarn start. npmi, sorry. We just cloned it.
We got some confirmation that
It is
clear.
I like to hear
It's
that.
looking good.
We'll open up a window in a different desktop just to see it render. Make this bigger. What else we got? We got the thing here. I'll move it over. So while I'm doing all of this, Jacob, what would be a good source for knowledge on NFT contracts?
Yeah, so what I usually do when I'm starting an NFT contract is I actually go to the OnFlow GitHub repo. I think it's called I think it's just called Flow NFT or something like that. But I usually just look up OnFlow GitHub, NFT repo, and I go and look at the NFT standard that the Flow team has shown, and they also provide a sample implementation called Example NFT. And usually that's really helpful to see how non-fungible tokens are actually implemented on Flow, with a very basic example, so that it's not too complicated, although it definitely is a little confusing at first.
How about we look at the Playground NFT? It's not.
Yeah, that's
it's not
exactly,
fully
yeah.
up to the standard, and it's got some simplifications there. But it should be pretty nice to follow with the setup that we have. And for everyone that's tuning in and who wasn't part of the live stream when we created this, this was all live coded, right? There was no prep code. So we click on sign in here. We get our FCL wallet provider pop up, and we select block though, and we log in. Okay. Now, after we log in, we can execute a script to fetch some data. So just interacting with the blockchain, and we can send some flow to a specific address. Now, I am noticing something that I did not push the changes from last time, because we had a little more functionality there. So I'll go ahead and try and commit that and push it onto the repo.
Yeah, I think that the Flow Playground with the non-fungible tokens, I think that's actually a great idea, because it's easy to see those NFT contracts in the Flow Playground with all the syntax highlighting and stuff like that, and the Playground, while it does have its limitations, it's easy to see the code. And I actually think it's pretty convenient, because the NFT tutorial that they provide through the Playground, I think, is actually the same sample implementation they do on the GitHub repo I was talking about.
Is that right?
Yeah.
In that case, Jacob, let's try this experiment. So I'm tweaking the repo a little bit. While I'm doing that, maybe you could share your screen and go over the Playground.
Now, I see we also have a comment here, so let me read this for a second. Hey Morgan, this is from Christy. Hey Morgan, yesterday I was going through documentation on Flow and tried loading kitty items, but was not able to log in. Can you try and verify it? I was going through. I'm not sure if that's. Are you talking about like the sample website that is provided by the Flow team for kitty items? Or what is that referencing?
I'm not sure either. Please specify or elaborate if you can.
So I actually am sharing my screen for the Flow Playground. I'm sure it's actually loaded up on the screen.
Yes, it is.
Perfect. So this is the Flow Playground. I'm sure many of you have seen this before. But just to kind of review, this is where you could do some, I guess, local development, and it's super easy for you, because you could just deploy contracts. We'll do this one, for example, this Hello World. We'll just deploy this one, and you see it's deployed, and then we can also run some sample transactions and scripts. But I know we've done this before, so I'll skip that. But what we were going to look at today is the non-fungible token. And you'll see that if I click that button up here that says click here to start a playground tutorial, a bunch of tutorials come up. And so you can see there's like a hello world one. That's what we were just looking at. There's some fungible tokens. And then there's also one called create non-fungible tokens. So it says create and shape your own unique digital objects. Here you'll learn what really makes blockchains magic, the ability for unique items to be created, shared, and stored forever. So like I was saying before, sometimes when you see this NFT craze, it's not as special until you actually see NFTs implemented.
Jacob, real quick, if you could zoom in, and that would help people.
Oh, yes.
Thanks, Manrad, for the suggestion.
Yes, thank you for that. Is this okay? I hopefully this is all right. Okay.
I'll let you know if someone complains.
Okay, perfect. Thank you. So let's actually take a look at this. So it looks like we have two just hello world contracts that don't really do anything. And then in account 2, it looks like, okay, so we'll start with actually account 1. So what's going on here is we've defined a contract called example NFT. And in it, it's just one thing. And it's an NFT resource. And so inside this NFT resource, usually what you would have inside an NFT is an ID, because you want your NFT to be unique. And the idea behind non-fungible tokens is that it's non-fungible. So, if I were to give someone a $1 bill and then I was to give you, a separate $1 bill, that would be the same thing, right? Both $1 bills are the exact same, and that's why it's fungible. But with non-fungible tokens, if I were to give you an NFT, I could never give you an equivalent NFT. And the reason for that is because the ID field for NFTs are unique. So you'll see here it says the unique ID that differentiates each NFT. And then we just have a dictionary that's a metadata, and this just maps, string to string. So any extra metadata we wanted to put in here, we can put in here, and that's simple enough. And then the only other thing this contract is doing is it's actually just saving an NFT or account storage, so that we can go back in there and get it if we wanted to. So we could deploy this contract, and we'll see that it actually gets deployed to our account. Now, if we wanted to have an official NFT, so when you think about NFTs, you can't just make up any NFT you want, because some of them could be malicious. And for example, on OpenSea, there has to be some sort of regulation behind NFTs, right? Because if I just made my own NFT contract, but I did it in a malicious manner where I sort of allowed NFTs with the same ID to be created or minted, that would be a problem, right? Because that means that the NFT is no longer non-fungible. It would be fungible at that point. And so there has to be some sort of standard around NFTs, and that standard is called the non-fungible token standard. And if we were to actually implement that into our contract, the NFT contract would look a lot more complicated than this, because you'd have to specify collections, you'd have to specify resource interfaces, it would have to specify a lot more. And so, Morgan, do you think it'd be helpful if we walk through that whole NFT example, or?
Well, with this amazing intro, I think we can start getting into the coding part of it, because after all, this is developer hours, right? So we took a look at the implementation, the basic implementation, the fact that we need an identifier for each NFT to make it an NFT, not a fungible token. And I think we can get started with some actual code here.
All right, so or if you wanted to do it, that's fine.
Well, I did pull the most recent update from GitHub.
Oh, perfect.
I just want to display that, and then we'll have our canvas, and we might work on that. We might work on Playground. We'll see. Sweet. So thanks, Jacob, for outlining what an NFT is in the most basic form. And our repo, just to recap, is at a state where after you log in, in fact, I'm going to sign in again with my Blockdo wallet. Confirm. And actually, Jacob, if you could create an account on testnet, I'll add you to this list, and I'll test it out by sending some flow testnet tokens.
So I could just send an address, right?
Yeah. So if you create an account on testnet while I'm explaining, I'll add you as soon as I get the address, and then we'll see your balance. So while Jacob's doing that, what we did last time was one of our developers created an account or shared their account with us, and we sent some flow tokens to that address. And I believe it's this D9C6 address from Mayrab, and we sent some tokens over there. This is my address, the one I'm logged in with, and my balance is 858. All right. When I reload the page, the system executes a script for every account address that it has in an array, and that array is let's see, inside of page right here. Okay, so we have an array of 3 addresses in the accounts array here, and when we load up the page, let's minimize these. Let's keep this open. Okay, and account fetch balance. All right, so this account component here, which we render for each individual account in this array, we provide it with an address, and then that address is used to fetch a balance, specifically to execute this FCL script. And then the result is a balance that we set as part of the React state and render it out onto the web page. So you can see when I refresh, you'll see loading for a tiny brief second, and then you have your balances up here. We also have the transaction example in this repository where we can select a number of flow, let's say 42, and send it to one of these accounts. So this has 1051. So if I send 42 more, it'll ask me to confirm this transaction, and I'll prove it. And what we should get after we refresh the page, now I'm waiting for the transaction to be sealed, so as to be sure that it was included. All right, so we got a status for good, and we reload, and we have 1093. So all good there in terms of the transfers. Jacob, how are we looking? Do we have another account?
Yes, I have an address for you. How can I send
Slack,
it to you?
YouTube.
All right, I will send it to you on Slack. My address.
Okay, let's copy that over. Add address number 4 in our array, and we'll do a couple of things. We'll take a look at the updated balance. So we see that Jacob is relatively poor. Okay. And let's share some of that testnet wealth, and let's send him 420 flow. How does that sound, Jacob? Okay.
That sounds great.
So
I
I'm
like
going to
that,
execute this transaction, approve it, and once I get a status message, we'll be able to restart our page, refresh our page, and then see this updated balance. Takes a little bit, nothing too big. And boom. So now, Jacob, if you were to check your balance, you'll be very pleased.
Yeah, let me check. Oh, I do. Yep. Yep, very pleased.
There you go.
420 flow.
So this is what you can do already
Nice.
in this repository, and we're just gonna add some more stuff on here by implementing an NFT, right, Jacob?
Mm-hmm. Yep.
Cool. So let's create a new folder for Cadence, and how should we call this NFT?
Let's call it. Well, I keep calling all my stuff
Oh, dear.
Morgan something. So
How about we call this one Jacob?
I would Okay, we
Or
can
let's call
call it
this
that.
the awesome, because everybody knows who's awesome. Um,
Yeah,
so let's
that's my
call it
term
the
now.
awesome nifty. I don't know. I don't like acronyms that much, so let's do nifty here. Um, okay, so when we describe an NFT, Jacob, we start with a contract. Is that correct? Like any kind
Yep,
of
exactly.
flow concept first starts as a contract. If you want to implement that. So let's do pub contract. Awesome nifty, and let's do an initializer, an empty one, and we're done, right? We don't need anything else. And the
Yeah, that's
stream
it.
right
Let's just
here
end the
while we're
stream.
ahead. No, but like Jacob said in the example, this contract should define a resource type that holds an ID, and that ID ensures the uniqueness. And yeah, so let's implement a resource. Pub resource NFT, and we're going to define a single field. It's going to be a constant u unsigned integer 64-bit, and we're going to provide the initializer, so the ID and same type. Okay, typing is hard, remember everyone. So we initialize it with an ID, and that's pretty much it. That's not that much fun, though. We want to store something, and we don't want to store an ambiguous thing or like a generic thing like metadata. Let's store something like an awesome nifty. What can we put in a string that's awesome?
Um, I'm not even sure. Yeah, so we're to find a string, we could put like name or something. I don't
Let's
know,
do
like the name
name.
of the NFT.
All right, so pub let name is a string, and we're going to initialize it with a name string. So our NFT is going to have an ID, and it's going to have a name. Okay, and that name is going to be the thing that sort of we identify the NFT with. Okay. So now, how do we store this, Jacob?
Yeah, so usually, in an NFT contract, we would want to store NFTs inside of some like a collection. Um, and so we would have to define a whole resource called
And,
collection
and,
in
and
order
why
to do
is that?
that.
Why do we
So
want to
that,
store it in a collection?
yeah, so the reason we want to store it in a collection is because, technically on Flow, it's true that you could store your NFTs in account storage one by one. But that would be super
Well,
inefficient, right? And every time you wanted to access an NFT, you would have to go into your account storage
let,
one by one and get those
let's implement a
NFTs.
basic sort of, let's see what's wrong with just storing it directly. So,
Yeah,
so
let's do that.
self.account
Yeah.
save, and we're gonna create an NFT right in the initializer, and we're gonna provide it with an ID. Let's say 0 and a name, and we all know what kind of name is that. It's gonna be Jacob, and add a new line here for readability. So we're creating an NFT, and then we're storing it directly to, let's say, storage slash awesome nifty. Okay, so let's say we publish this contract, we create that NFT, and we store it there. What happens when we want to create the next NFT? Well, either we overwrite the existing one, which we can't, we would need to destroy it, or we create a new account to store the new NFT, because at that address, at that path /storage/awesome nifty, we can only put one thing, right? It could be an array, it could be a dictionary, but it's still one thing. And in this case, our one thing is a resource that contains an ID and a name. So it's not an aggregate, it's just it's all by itself. And that's not good. We want to be able to have 0 or more things. And the way to solve this is by creating a collection, just like Jacob mentioned. Now, a simple collection would probably just have an array or a dictionary of NFTs, and we could put that into storage and leave it be, right? So let's define one. Pub resource collection. Okay. Now, like we mentioned, that's going to have array or a dictionary. What do you think, Jacob? What's best?
Let's do a dictionary, and what we can do is we can map the ID of the NFT to the NFT itself.
Good suggestion. So let's create a dictionary. We are marking it though as a resource since it contains resources, and resources all the way up have this distinction here. I see a comment from Mayrab on Slack. I don't know if you remember, I faced issues during passing at, so Mayrab had issues when he was interfacing with the Flow CLI and trying to pass dictionaries. We'll take a look at that. I'm on a Mac at the moment, and we'll be sort of dealing with the FCL at the moment. So we'll take that offline, Mayrab. All right. So this dictionary right here, the key is going to be uint64, and the value is going to be of type NFT. Okay. So now it's complaining it needs to be initialized. Okay. We declare an initializer. It's not going to take in any arguments because, well, we don't have to start with a full list of nifties. We initialize it with an empty dictionary. It's still complaining, missing destructor. Okay. So when a resource is destroyed, if it has resources inside of it, we need to explicitly tell it how to dispose of those resources. And just like the init function, we have a destroy function, and we're just going to call the destroy command on self.nifties. Okay, and now this collection is sort of complete. We have a dictionary of nifties. We initialize our nifties with an empty dictionary, and upon destruction, we destroy the self.nifties. Okay, now as a convenience, let's create a pub fun create collection. So then the only place where you can create resources is within the source code of a contract, and during a transaction when we're setting up an account and so forth, we'll be creating resources. So we want to be able to do that, and to be able to do that we need to write up a wrapping function where we create a new collection. So that's going to return an add collection, and we create a collection resource. So now when we initialize our account in the beginning, we no longer create an individual NFT, but we create a collection. Okay. So we create that collection, and you know what? Maybe we can use the self.create collection function. Just everything's fine. All right, and then we're storing it to the awesome nifty collection path, just for explicitness. Okay. Now, what are we missing, Jacob? We have an NFT and we have a collection. That seems like that's all we need, right?
Yeah, so it seems like we're all good and fine, but the question that I have is, how are we going to mint NFTs? How are these NFTs actually going to come to life? And who's going to be, the admin there? Could anyone create an NFT? So these are, I guess, like the next
And
questions to
what do
answer.
you think, people in the chat? Would anyone be able to create an NFT here? Would everyone? Would someone? No one? That's yeah.
Anyone? Anyone? Anyone?
Please raise your hand. While we wait, it's always good to consider just the source code and see what's described in there, right? It's a pretty simple contract, only 35 lines of code in there. And I assume no one has an idea because no one's commenting. So we're just gonna remove all secrecy here. There's no way to mint NFTs. Like I said, with collection, the only place where you can create a resource is within the source code of a contract. There's no function that we can call to create a resource, an NFT, or anything similar. So thus, this contract, if we ship this, well then, that's it. That's the end of it. So we need a new resource, a resource that will be able to mint NFTs, right, Jacob? So
Yep.
on with the work. Pub resource, let's call it Minter. And what's a regular minter to do? Can you describe it for me, Jacob? What primary functions there?
Yeah. So the primary function of a minter would be, obviously to mint an NFT, and we could do this just by having some sort of function inside the minter, maybe called mint NFT, and all it does is return an NFT back.
Since we have a parameter called name, how do we initialize that?
Yeah, so if we wanted to, I guess we have to pass in a name for the NFT. We would have to have a parameter inside the mint function called name, and so the person that wanted to mint the NFT
Sweet.
could just pass it
in. So we
in.
have this pub fun mint, and let's create an NFT. So NFT assigned by creating an NFT with now. When we're creating an NFT, it requires an ID. What kind of ID do we use?
So, with these IDs, it's not smart to pass in the ID, and this is because whoever's passing in that ID could make a mistake, right? So instead, we want it to be sort of automated in that we want, each ID to be unique, and so we can do that by like a total supply that gets automatically incremented every time a new NFT is minted. So it starts at 0, you mint, let's say it's now 1, 2, 3, 4, 5, up until infinity. And so that way there's no room for any mistakes.
So let's create a total supply variable, pubvar total supply. Since we can't go into negative supply, I guess, let's make it an unsigned integer. And with that, we need an initializer. We need to set it to something, and let's set it to, I don't know, 0, right? Total supply 0 when we start. And so we can use self.total supply plus 1, or should we start with just total supply and then okay.
Yeah. Because
so then we have to make sure to increment it, right? After we mint, and then once we did that, let's return our NFT, and I believe that's it for the minter, right? Now we just have to add it to our account. So we saved a collection. That's all good. Now we just need to self.account.save a minter. So we create minter. store it to storage / awesome nifty minter. Okay, so now we have that in storage. The other part that is sort of lacking here, if we wanted to receive an NFT from someone, we can't really do that without authorizing, because we just have it in the collection, we have it in storage. We want it accessible to third parties without our authorization. We want to be able to receive these nifties, right? So in comes a thing that's unique to Flow and Cadence, and that's interfaces. Okay, we can define an interface for this collection here that will allow us to expose just a specific field or function or combination of those. Yeah. Oh, I forgot. We don't even have a deposit and withdraw functions here. So we should implement those first. Or you know what? Let's start with an interface. So pub a resource interface. And let's see. So our receiver, right? The interface that we want to provide to the public is going to have really just, I guess it could have one exposed function, the deposit. What do you think it needs more?
Yeah, so we have, now we have the deposit, but we also need probably some sort of withdraw in order to be able to, take NFTs out and manage them how we want.
Okay, but is that part of the receiver interface? Because we're
Oh, part of the receiver? Oh, no. So if for the receiver, yeah, we just want to be able to deposit, and that should be.
What if we want to list
that should be
what
fine.
NFTs do we have?
Yeah, so if we wanted to list our NFTs, I guess we could have some sort of function that just returns all the
Let's do
IDs
that.
that we
So
have.
pub find get
yeah.
IDs, and that's going to return. Let's see here. Well, that's going to return a bunch of uint 64s. 64. Okay, so we have this interface now. If we want to mark our resource as a resource that implements that interface, we do colon and then add the name. Now we have a complaint because resource awesome nifty collection does not conform to the interface. And that's because we don't have a deposit and we don't have an IDs function. So let's add those deposit. So we take in a nifty at NFT, and that's a simple function. We reference our nifties dictionary, and we look at the nifty ID, and we move the token there, or rather the nifty. Now we have a complaint here. It says cannot assign to resource typed target. Consider force assigning or swapping. You'll find these issues when dealing with collections, both dictionaries and arrays that are filled with resources, in that you can't just go about assuming that you can move things in and out of them. And I say moving because we're working with resources here. So let's follow the advice of adding this exclamation mark. So we're force moving this nifty into the nifties dictionary. Okay, so that's our deposit. Let's look at our get IDs. So pub fun get IDs. We return uint 64. And let's return self.nifties. Now, I would look at the docs, right? But the VS Code editor kind of neatly suggests that there's this keys thing, and it describes that as an array containing all keys of the dictionary in the type that's defined. Okay, so that's exactly what we need. We just need all the keys that are in the dictionary in our collection. So we have this deposit thing. Now the final part is we want to move things in and out. So right now we can only move things in. Let's add a deposit function, or rather withdraw.
And with that, it is that time of the day again. I have to run, but this was great again, and
Thanks,
I'll
Jacob,
catch
for
you guys in
joining
the
us.
next one.
Always a pleasure. Bye.
Yep. Bye, Morgan.
So with that sad note of Jacob leaving us, we're left to our own devices to complete this assignment, and I think we should be able to do that. So when we're withdrawing a token, we're withdrawing by referencing it with the unique identifier that it has. Okay, so we can use the nifty ID, and that's a unsigned integer. The auto completion never ceases to surprise me. Okay, so we marked it as returning an NFT. So we want to take out the nifty from our collection, and that's the nifties, and we remove. Okay, so we can take a look at the documentation, because it's always a good habit to form whenever you're thinking out loud of what you need, what kind of functionality that you need. Always explore what's available in the docs. So when we look at values and types, let's look at dictionaries. So what is available here? Fields and functions. We've got length, we got insert, so when we're adding at a specific key. And look, we have remove. So what remove does, it removes the value for a given key from the dictionary and returns the value of type V as an optional, okay? Keyword on the word optional. If the dictionary contained the key, otherwise it's going to be nil. So that's exactly what we need. We need to remove our nifty from our nifty's dictionary. And we're going to call the remove function here. Okay. So the key that we're providing is the nifty ID. And that's all fine. But the problem here is we're returning an optional. Now, if we don't have a nifty with that ID present, well, we want this this to fail, and it will fail if we call this if we force unwrap an optional and it does not contain a value. Okay, so we force unwrap it, we set it, and then we can return the nifty in the return statement. Okay, so this kind of completes our collection. So now we have a minter, we have a receiver interface, and let's add to our account a public interface. So or capability rather. So we do self.account link, and link creates a capability. We're gonna link with public / awesome nifty collection, and the target for this public interface is going to be storage awesome nifty collection. Okay, now there is a problem here. It's expecting us to define what kind of type this is. Now this is where the interface that we define here for receiver comes in handy, because we can define the type in these angle brackets as a reference, and then curly braces, and in those curly braces we provide the interface. Okay, so what this means that this public capability will have everything that's defined in the receiver interface. So it will have this deposit function and this get IDs function. Okay, so now we're truly done, and we should be able to deploy this contract. swiftly here. All right, so we take the source code here and go to testnet.flow. Let's see here. So let's go to flow view source / testnet and / account. And what's my address? If I run execute script, I should get my address. And if we go here, we'll see that I don't have any contracts deployed. Okay, let me authenticate. Confirm. Okay, so now on flow view source, I can add a new contract, and the contract's right here. I'll go ahead and paste that in and deploy. So let's wait until it completes, or rather sign it. Okay, it says it's executed. It's always a good sign when you see your transaction getting executed. We didn't make any ABZ. Sorry if I missed you. Too many screens covering the chat. Okay, so we have this contract deployed, and if we reset this page, we'll see it in here. So now we can try and interact with it somehow. Inside of account, I guess. Let's see. Our interface over here has this balance. So what we can do is do a little script. So now we have a script that fetches a balance. We can add a script that check for collection, or rather check collection. So check collection is going to just look at a given account and determine if that account has an awesome nifty collection or not. So at this point, we could just copy over some of this source. Let's look in here. So the contract lives with this account. So let's replace that. The contract name is awesome nifty. Awesome nifty. And we're gonna look for a collection reference. So we get the account and then the capability. Remember, we defined that capability in the initializer. So it lives in /public awesome nifty collection. Okay, so let's use that there. And then when we borrow it, the type is going to be awesome nifty dot receiver. Okay, and just couldn't borrow collection as our error here, panic message. Okay, and so this is an optional, so we're fine with that. All right, so if we're going to return a Boolean value, and that value is going to be, let's see here. So if this is nil, then we return true. Otherwise, we return false. Okay. We feed it an address. Has collection. Oops, has collection. And then decoded. So let's just console log it for now. Has collection. Okay. So this reloads, and let's check. Oh, we didn't call it. We have to call it in the use effect here. So props.address. And yeah, that looks right. Reload. All right, so we're getting a little a weird result. So we have 3 trues, even though we only set up the collection with 1 and 1 false. So it has to be the other way around. So if this is nil, and the question is has collection, so yeah, let's flip these around. So it's false and true. Okay, so false, true, false, false. That is good. Let's use state here real quick. So const has collection set has collection. Use state. So they'll start with null, and we'll do another span right here, and has collection if this is true, yes, otherwise no. Okay, and over here we'll just set has collection to the latest value. Let's see if that works. So our account has a collection and these 3 don't. Okay, that seems about right. Let us create a button here for creating a collection, and then let's see that in action. And yeah, so let's look here. When we send our flow, we execute a transaction. Okay, so let's take that, move it over to account. So we have check collection. We don't need this for now. Let's add. So on create collection. Okay. So we're going to have a button response, and we're interacting with this contract right here. And what are we doing? So we have an account. Let's see here. We don't have anything in the execute block, so that's fine. And in here, let's do collection. We're going to save the awesome nifty, and what's in the contract? Create collection. So we're going to create a collection, and then we can account dot link, or rather, first we save it. Okay, so we can take a look at what happens here. So we have a save and a link. Okay, so account save this collection. So now what the resource is done with, we're good in this location. And then we link the receiver. Now, since we're working outside of the contract itself, we need to namespace everything that we're referencing from the contract with the contract name dot and then whatever we're linking to. Okay, so we're gonna save, and then we're gonna link. Okay, so that takes in the address. Oh, it doesn't take in anything. Just we need to sign it, so that's good. So we have the authorizer, which will be achieved by us signing it. Okay, so and at that point, we can try it out. Oh, we need a button. So if has collection, rather, if has collection is false, then we're going to render a button to create collection. And this is going to have an on click, and that on click is going to on create collection. Okay, see if that works. All right, so these buttons appeared on the accounts that right, don't have a collection. Now the thing is, when we want to test this out, we need to get another account in here that I have wallet access to. Otherwise, you know, I can't create a collection on this account since this account does not belong to me. So let's, for demo purposes, let's sign out and sign in with a different Blockdo account. Use another account. Okay, bear with me. A little privacy here. Let me find my inbox. One moment. Okay, so we got our ID. Okay, so we logged in. Let's execute the script, fetch our account ID. It's not in the list, so let's just add it to the list. Okay, sweet. So I have an account with 1014 and I don't have a collection. Now if I click this create collection, it should execute a transaction to create a collection, which I'll need to sign for. Sweet. So we have this. We can take a look at the source code. Looks all right to me. Authorize it and wait to see what happens. So we have a transaction ID right here in the console. It came through. So if I refresh, boom, I have a collection. Okay. So we were able to create a collection for an account that we have access, or rather signing privileges to. All right. So that's that for, you know, creating collections. I am going to, I guess we should end it at this point, because when thinking about it, sending NFTs and withdrawing, depositing could be another 15 to 30 minutes worth of content. So yeah, I'm gonna cut it short, or rather stop right at the clock here. We explored what it means to create an NFT contract. We have the very basic primitive contract in the repository here for Mercury Hopium, which I'll publish a commit to as soon as the stream is over. And we discussed on the required aspects of that contract, specifically having a receiver interface, storing, creating a public capability, having a minter, having collections, and so forth. So hopefully this was useful as an insight to creating Flow NFTs. Next Flow Developer Hours, we'll create NFTs and we'll mint them, we'll deposit them, we'll withdraw them, and we'll get to interact with them a little bit. And if you want to work on this repository in the meantime, feel free. I'll let you guys know when the commit is up. But from me, for now, that's it. Thanks for joining. And yeah, from the team at Decentology, I bid you farewell, and I'll catch you on the next one. Bye, folks. Catch you on Slack.